Hello, and welcome to the CCNA Routing and Switching course offered by SimplyLearn. In the previous lesson, we focused on layers 7, 3, and 4 of the OSI model. In this lesson, we will discuss IPv4 addressing and subnetting. Let us begin with the objectives of this lesson in the next slide. By the end of this lesson, you will be able to discuss IP addresses, convert binary numbers to decimals, discuss classes, create subnets. Let us begin with an introduction to IPv4 addressing. An IPv4 address, hereafter called an IP address, is a 32-bit numeric identifier assigned to each device on an IP network. It is assigned in software and has no relation to the underlying hardware. The format is dotted decimal. It consists of 4 numbers separated by periods, dots. For example, 192.164.2.1 is a valid IPv4 address. There are 3 major types of IPv4 addresses. The first is unicast, where the packet is sent to only one device. The second type is multicast, where the packet is sent to many devices. The last type is broadcast, where the packet is sent to all devices in a network or subnet. For example, the broadcast address for the network 192.168.1.0/24 is 192.168.1.255. IPv4 addresses can also split into public and private addresses. Public addresses are those that can be used over the Internet. Private addresses are used only within a local area network, LAN. Let us find out more about private addresses in the next slide. Private addresses are also called Request for Comments RFC 1918 addresses because it is the name of the standards document that defines them. They can only be used within a private network and cannot be routed through the Internet. Therefore, they are also called unroutable addresses. The significance of private addresses is that by using them, the organization needs fewer routable addresses. Public addresses cost money. Devices with private addresses can still access the Internet if Network Address Translation, NAT, is implemented. NAT lets a LAN device borrow a public address when it needs to access the Internet. Next, let us look at binary numbers and how to convert them to decimal. Binary numeral system sends signals that are interpreted as either 0 or 1. This means it includes only the digits 0 and 1. The decimal system, on the other hand, uses 10 symbols, 0 to 9. When quantities higher than 9 are required, the decimal system shifts to 10. This notation means 110 and 0 ones. Each digit added to a decimal number signifies a power of 10. For example, the number 134 equals 1 times 10 to the second power plus 3 times 10 to the first power plus 4 ones. Binary numbers are decoded in the same way as the decimal system, except that it uses only the 2 symbols 0 and 1. In the next slide, we will look into bits and bytes. Let us begin by defining few terms here. A bit is 1 digit, either a 1 or a 0. A byte is 8 bits. An octet is a byte used in the IPv4 address dotted decimal format. An octet can have 8 bits. The rightmost digit is the number of ones. Successive digits represent a higher power of 2 as you proceed from right to left. Let us continue our discussion on bits and bytes in the next slide. The table on the slide highlights what it means when a 1 is in various digits of the number. For example, if a 1 is in the 6th digit from the right, this represents 2 to the 5th power, or 32. Now let us convert binary to dotted decimal format in the next slide. A dotted decimal address in binary is 4 bytes separated by periods. The decimal equivalent is 192.16.13.1. To pass the CCNA exam, you must be able to convert binary to decimal addresses. We will discuss how to convert binary to decimal addresses in the following slide. To convert 10110001 to a decimal number, find the place values of 1 bit in the binary number. There is a 1 in the 2 to the 7th place, which equals 128. There is a 1 in the 2 to the 5th place. The decimal equation becomes 128 plus 32, which equals 160. There is a 1 in the 2nd to the 4th place. The decimal equation becomes 160 plus 16, which equals 176. Finally, there is a 1 in the ones column. Now add 1 to 176. The result is 177. Therefore, the decimal equivalent of the binary number 10110001 is 177. In the next slide, we will discuss special addresses. There are 3 types of special addresses. They are host, network, and broadcast address. A host address refers to an address that can be assigned to a network device. A network address refers to an address that represents an entire network. A network is normally denoted by the network address and prefix length. Prefix length is the number of bits of the address that are same going from left to right for all hosts in the network. For example, 10.0.0.0/8 means that 8 bits remain the same for all the network devices. 8 bits is the first byte of the address. Thus, all addresses in this network have a 10 in the first octet. Broadcast address refers to the last address belonging to the network. It is used to send information to all nodes on a network. In the next slide, we will look into the valid host addresses. Valid host addresses are addresses between the network and the broadcast address. The number of valid host addresses is 2 to the n minus 2, where n is the number of host bits. For example, consider the Class A network 10.0.0.0. All host bits set to 0 is the network address 10.0.0.0. All host bits set to 1 is the broadcast address 10.255.255.255. The valid host addresses are 10.0.0.1 through 10.255.255.254. Let us now look at an example of Class B network 172.16.0.0. All host bits turned set to 0 is the network address 172.16.0.0. All host bits set to 1 is the broadcast address 172.16.255.255. The valid addresses are 172.16.0.1 through 172.16.255.254. Consider a Class C network 192.168.100.0. All host bits set to 0 is the network ID 192.168.100.0. All host bits set to 1 is the broadcast address 192.168.100.255. The valid host addresses are 192.168.100.1 through 192.168.100.254. Let us focus on subnet masks in the next slide. A subnet mask defines the number of bits that represent a network and subnet part of the address. This corresponds to the prefix length. The subnet mask is used for 2 purposes. The first purpose is to identify the destination IP address as either local or remote. The second purpose is to determine network path for Layer 3 devices. For example, the subnet mask for classful network 172.16.0.1 is 255.255.0.0. This is the same as a prefix length of 16. Let us find out about subnets in the next slide. Class A, B, or C networks can be subdivided into smaller networks called subnets. These subnets are part of the larger classful network the class A, B, or C network that the first octet indicates. Therefore, subnetting a network can be considered, dividing it into subnets and also how many subnets can be contained in a network. There are several advantages of subnetting. Smaller networks are easier to manage. Also, overall traffic is reduced. In addition, network security policies are more easily applied. In the next slide, let us learn how to create subnets. Subnets can be created by borrowing bits from the host bits to create a subnet field. The process is as follows. Using 1 bit for the subnet field results in 2 to the 1, or 2 possible subnets. Using 2 bits for the subnet field results in 2 to the 2, or 4 possible subnets. Using 3 bits for the subnet field results in 2 to the 3, or 8 possible subnets. Using 4 bits for the subnet field results in 2 to the 4, or 16 possible subnets. Using 5 bits for the subnet field results in 2 to the 5, or 32 possible subnets. Using 6 bits for the subnet field results in 2 to the 6, or 64 possible subnets. With 6 bits for the subnet field, only 2 bits are left for the host. That yields 2 to the 2, or 4 hosts. Remember that 2 addresses are set aside for network and broadcast address. Therefore, there are only 2 host addresses available. At this point, no more subnetting is possible. A variable length subnet mask (VLSM) address uses such subnets. This is the opposite of a classful mask, which has a fixed length. There is something to take into consideration when counting the number of subnets, the IP subnet 0 command. Let us move on to the quiz questions to check your understanding of the topics covered in this lesson.